Hello everyone, welcome back to my channel. I am Praniti Reddy from Sri Venkateshwara College of Engineering, studying second year of BTech, and we are going to discuss about 0, 1 matrices and directed graph. 0, 1 matrices and directed graph. Welcome to this visual journey exploring 0, 1 matrices and their connection to directed graph. These mathematical tools help us model relationships and structures in various fields. From computer science to sociology, understanding these concepts enables us to analyze complex network clearly and effectively. In this presentation, will 0, 1 matrices explain how they represent directed graph. What is 0, 1 matrix and how does it relate to graphs? 0, 1 matrix definition. So, a 0, 1 matrix consists exclusively of zeros and ones, representing absence or presence of a relationship between elements. Relation to directed graphs. Each 0, 1 matrix can represent a directed graph where 1 indicates an edge from one vertex to another, and 0 means no edge. Visual representation. This matrix forms the adjacency matrix of the graph, allowing easy computation and visualization of network connections. Key concepts: vertices, edges, and adjacency matrices. Vertices, which is known as nodes, there are fundamental units or points in the graph, representing entities or objects. Edges, which are known as arrows, directed graphs connect vertices, indicating relationships with directionality from source to target. Adjacency matrix, a matrix where element ij is 1 if there is an edge from vertex I to vertex j, as 0, encoding the graph structure compactly. Constructing a directed graph from a 0, 1 matrix, which is a step by step guide. First one is to identify vertices. Assign each row, column, index to a vertex in the graph. The second step is read matrix entries. For each one in matrix position ij, add a directed edge from vertex I to vertex j. The final step is draw the graph. Represent vertices as points and edges as arrows, according to the adjacency matrix. What is 0, 1 matrix and what are its real world applications? So, the network analysis and beyond. So, there are 3 points. So, the first one is social network analysis, and the second one is traffic and routing, and the third one is computer science. The first one explains how mapping friendships and interactions are directed, edges for insights into influence and communication flow. The second one is traffic and routing, modeling directed paths in road networks or data routing for optimization and efficiency improvements. The third one is computer science, which representing the state transitions, dependency, and flow in and software design. Exploring graph properties through matrix operations. There are again 3 points, which is path counting, detecting cycles, connectivity analysis. So, path counting refers to the matrix powers reveal the number of paths of various lengths between graph vertices. Detecting cycles, repeated diagonal values in matrix power can indicate cycles in the graph. Connectivity analysis. This represents the matrix operations help assess reachability and connected components in directed graph. Let's see a case study of mapping social connections with 0 and 1 matrices. There's a table of person which is Alice, Bob, Charlie, and Diana. So, this adjacency matrix captures directional friendships in a small social group. So, showing who follows or interacts with whom. Such representations enable analysis of influence, clustering, interaction patterns in communities. Summary. So, key takeaways and further exploration. So, 0 1 matrix simplify graph representation. They encode complex directed graphs, compactly facilitating mathematical analysis and visualization. Matrix operations reveal graph properties. Insights like path counts, cycles, and connectivity merge through matrix multiplication and powers. So, applications span multiple domains, social networks to computer algorithms. These concepts are essential for understanding and modeling relationships. Further exploration considering studying spectral graph theory or advanced network analysis methods to uncover deeper insights in directed graphs. Thank you.